Hey, good morning guys. Today is Tuesday and hopefully you guys had a nice 3-day weekend. I'm relaxed and you're ready to start learning again today. So today we're going to be talking about exponents and powers. And so notice how I have notebook paper right here. You should have your notes notebook. Everyone is required to have a notebook for math. And you're supposed to be keeping your notes. So today's the first day that we're really starting to take actual notes. And when you come back to school, I will do a notebook check, and that will be for a test grade. So make sure you're using your notebook, okay? So let's talk about exponents, okay? So let's say I've got 3 friends who really like to shop. Okay, and each friend has 3 bags, and in each bag there are 3 shirts, and each shirt has 3 buttons. Okay, well, if we're listening to me tell that story really quickly, then we're probably understanding that there's going to be some multiplication because there's some 3 times 3 stuff going on there, right? So let's break it down for a second, okay? I said, first let's give our notes a header. Exponents. Okay. So I said I had 3 friends and they really like to shop and they have 3 bags. And each bag has 3 shirts. And each of the 3 shirts has 3 buttons. So if I were to break that down into a math problem, then what I would be saying is that 3 times 3 times 3 times 3 can represent this story that I told, this word problem, okay? Let me try and autofocus the camera a little bit more. Okay, there we go. All right, so, and if I did my math, I could say, okay, well, 3 times 3 is 9, and 3 times 9 is 27, and then 3 times 27 is 81. Okay, so all of that equals 81. But there's a little bit of a quicker way to write it all. So it's kind of like a shortcut. It's like a math shortcut. So the shortcut is to write using, powers. Okay? And I'll show you what I mean. Okay, so my math problem was 3 times 3 times 3 times 3. And so when I use a power, I can rewrite this whole thing like this. 3 to the 4th power. Okay? And so basically what I'm saying is I'm multiplying 3. 1, 2, 3 times, but I'm using 4 3s. Okay, so let me explain a power for you, okay? So 3/4, that's our power, okay? This whole thing is our power, okay? This, the big number, is called our base. That's the number that we're going to multiply. And this is our power, and that's the number that tells us how many numbers to multiply. Notice I didn't say how many times to multiply. I said how many numbers to multiply. Because if we go up here, how many 3s did we have? We had 4, right? So we multiplied 4 3s. But we did not multiply 4 times because look, count the multiplication signs. 1, 2, 3. We only multiplied 3 times. So the power tells you how many bases to multiply. Okay? So, definitions. Power. The product of repeated factors, right? Because each 3 is a factor. Then the product is the result of multiplying factors. So that's your answer, essentially. Then the base, remember we said that was this, right? The big number is the factor that gets repeated. And then the exponent, or the power, I'm sorry, I shouldn't have said that. This is not a power. I am so sorry. This is an exponent. So the exponent is the number. Sorry, my lights in my room just went out. Of times the base is repeated. Okay? And remember, whenever I'm taking notes, you should be taking notes. So when you come back to school and I open up your notebook and I look to the first page, your page should look very similar to my page, okay? It should not look very different than my page, okay? Okay. So there are a couple of special ways to read powers. I'm going to move this up. Remember, if you're still writing and you're trying to catch up, pause the video and continue writing. Okay, so how to read a power. So here's the power. I'm going to make a little chart. And on this side are the words. Okay. Now this is a special power. This one right here. So if I do 3 to the second power, I have a special way of saying that. Some of you might remember this. You might have seen this in fifth grade. It's called squared. So I would say 3 squared. This next one is also a special power. It's got a special name. So I've got 3 to the third power. And the way I would say that one would be 3 cubed. Okay? Then we go on and we just, from every other number after that, we'll go down. Let's go down. Let's skip a couple. We'll go to 3 to the 10th and 3 to to the 12th, okay? So 3 to the 4th is 3 to the 4th power. 3 to the 5th is 3 to the 5th power. 3 to the 10th and then we've got 3 to the 12th. Okay. Okay, so now that we have kind of finished our note part, let's do a little practice, okay? So, you're going to write these problems down. 4 times 4 times 4 times 4. And remember that when you see a little dot in between two numbers, that's our new way of doing multiplication. You should have seen it in 5th grade, but if you haven't seen it in 5th grade, that's okay. Anytime you see a dot between two numbers, it's telling you to multiply. It's the new way that we'll use it most of the time in middle school, and that's because that X that we typically used to use when we were in elementary school, we're going to start using X's for other things, and they're not going to mean multiply anymore. So we're going to get used to using that dot, okay? And then B is 12 times 12 times 12. Now go ahead and right underneath these two problems, pause the video and solve them. Write them as a power. And remember, if you can't remember how to write them as a power, you have your first pages of notes to remind you how to write them as a power, okay? So go ahead and write them as a power. Pause the video. All right. Hopefully, what you did was you said, well, I'm multiplying a bunch of 4s here, so 4 is my base. And I am multiplying 1, 2, 3, 4, 5 4s. So that means my answer for that one is 4 to the 5th power. And then on this one, I'm multiplying a few 12s together. So 12 is my base. And then I'm multiplying 1, 2, 3 12s together. All right? Hopefully your answers match mine. If not, hopefully you listen to how I solve them. Okay. Now, let's go ahead and solve these. 7 to the 2nd, 5 to the 3rd, 11 to the 2nd, and 4 to the 4th. Okay? So I want you to go ahead and solve those 4. So hopefully you pause the video and you work them out and you try to figure out how do I solve them. Well, 7 to the 2nd, well, I know 7 is my base and I have 2 bases, 2 of those 7s. So that means I have 7 times 7. And if I solve that, 7 times 7 is 49. Okay, number or letter B, 5 to the 3rd or 5 cubed. All right, so 5 is my base, and I know I have 3 5s that I'm multiplying. So that means I'm doing 5 times 5 times 5. 1, 2, 3, right? So 5 times 5 is 25. And 25 times 5 equals 125. All right, for C, hopefully you realize that you have 2 11s. So it's 11 times 11. And when you multiply that, you should come up with 121. And for the last one, hopefully you saw 4 was your base and you're using 4 4s. So I've got 4 times 4 times 4 times 4. And 4 times 4 is 16. 4 times 16 is 64. And 4 times 64 is 256. Okay, one last thing I want to talk to you about, and that is called a perfect square. So a perfect square, I'm going to continue right here. A perfect square is the square of a whole number. Okay, that sounds confusing. The perfect square is the square of a whole number. What do you mean, Mrs. Rodriguez? Okay, I'm going to show you. Ready? Okay, remember that I said that when you see a 2 as the exponent, that makes it a special power, right? And what did I say it was called? It was called a square, right? So, if I had 1 squared, my solution to 1 squared would be 1 times 1 equals 1. Okay? So this is the square of a whole number. 1 is a whole number, yes? Okay, so we can do that again with the next number. So the next number would be 2 squared. And 2 squared, you know, we're going to use 2 2's. So 2 times 2 equals 4. So that's a perfect square. When you take one whole number, you multiply it by the same whole number, and the answer is your perfect square. Okay? Let's do 4 squared. 4 times 4, 16. 5 squared. Oops. 5 times 5, 25. 9 times 9, 9 squared, 81. Okay, so now I would like you to tell me if these are perfect squares. I'm sorry, 64. I kind of just gave you the answer for that one, so I'm going to just go ahead and say. So if I ask you, is 64 a perfect square? What I'm asking you, is there any number that multiplied by itself will equal 64? And hopefully you know your multiplication times tables, and your answer would be yes, 8 squared. Okay? All right, now tell me, is 20 a perfect square? Go ahead and try and figure that out. Pause it if you need to. When I think about 20, I can think about all the factors that go into 20, and I know that there's no factor multiplied by itself that will equal 20. So 4 times 5 equals 20, but that's not the same factors, right? And 2 times 10, 1 times 20, but there's no number that perfectly goes into it, so it's not a perfect square. So the answer is no. Okay, let's do just a couple more on your own. Is 25 a perfect square? Is 2 a perfect square? Is 99 a perfect square? What about 100? Is that one a perfect square? Okay, hopefully you paused the video and you've worked them out. So for letter C, 25, is that a perfect square? Is there a number that if I multiply it times itself, it will equal 25? Hopefully you came up with yes, and your answer should be 5 squared. Okay, 2. Is there any number that when I multiply it by itself, I get 2? Well, I could do that one really quick. 1 times 1 is 1, and 2 times 2 is 4. So no, there's no number. Not a perfect square. 99, same thing. Is there a number multiplied by itself that will give me 99? Well, that's kind of high, and I know it's near 100. So I could go 9 times 9 is 81. That's a perfect square, but it's not 99. And then 10 times 10 is 100, and that's a perfect square, but it's not 99. So hopefully you just answered the next two with that same question. So 99 is not a perfect square, but 100 is a perfect square because we just said 10 squared, or 10 times 10 equals 100. Okay. So you are going to continue on with working with exponents today. I have some practice problems that you're going to work with, and try to get really familiar with calling it a power, and knowing that the small number that's up top is your exponent and the big number is your base, and how to use them, okay? And remember, refer back to your notes regularly so that you can get really good at it, okay? All right, hopefully you guys enjoyed this lesson.